Hello, everybody. Happy New Year. It's 2016. I think it's going to be a very big year. I want to share a few things with you today. Specifically, I want to start by sharing just how is HP thinking about the 3D printing market and our role in it, give you a sense of that for context. I want to share a little bit of information about markets that we've participated in for quite some time that have focused on driving the analog to digital transformation. And I'll show you a specific case study. I'm kind of a show me person, and one of the things that this case does is it really shows the power of digitization and what it can do in terms of unleashing new value. Ultimately, the focus of today's presentation, though, was to give you a sense of some new technologies, and so we're going to plunge a little bit into our Multijet fusion technology and some of the underlying core printing technology there. So first and foremost, the thing that I want to make really clear is, he mentioned the hype cycle. And I think we've gone through and are moving through the trough of disillusionment and finally moving on to practical application. And as we look at 3D printing technology, we absolutely believe this is a transformational technology. And we say that not just because of what we've studied, what we've learned, kind of an academic perspective, but more because we've experienced it. And in that case study I'm going to show you, I'll show you where we've done that and why we think that will apply for 3D printing specifically. Having said that, what we also believe is that this really needs to start from the process of innovation itself. And that is probably the area that we need to focus on the most initially before we realize that ultimate state of complete world transformation through 3D printing. And the reason for that is if you think about the gap between design intent and what's realized out of a technology, if you wanted to take full advantage of what 3D printing promises, we're still a long ways from what we would need in order to take advantage of that. And in fact, graphically, if you were to kind of describe what, where we are today between design intent and what's materialized out of systems, we're on a bit of a rickety bridge, and what we need to do is really work to advance the state of the art with things like what Jennifer shared earlier, so that we can move from that kind of rickety bridge to something that is really scalable. So as HP, one of the things that we also see is that back in the 1980s, when we entered the printing market, one of the things that we were able to bring was the ability to help the industry settle on standards, take friction out of the processes, make the technology much more addressable to a much wider group. We see a very similar opportunity there. Now, before going into the technology, I want to spend a couple of minutes talking about this idea of digitization. And provocatively, I like to say that it's not about 3D printing. 3D printing is a way of materializing things into physical form once they've been in digital form. But that's really where the power is. When things are in ones and zeros, you can manipulate them, you can transmit them, you can optimize them. There's so many things that are possible. But then you need fantastic technologies for bringing that back into physical form. So as we think about this, this is a slide that we actually developed for one of our businesses many, many years ago. It's not very well known, but HP has a very big business in graphic arts. And as you think back in history to the advent of the internet and Amazon coming into the market, they really changed the way demand happens and how it's served, more importantly. And as a result of that, what you saw are these dynamics of the long tail of interests, increasing variation. And so the fundamental tools to support that demand needed to change as well. So some of the benefits that you would point to for digitization in the context of 3D printing would be that you can have very unique geometries that can't be produced any other way, as we well know, but potentially repeated on a massive scale. And in addition, you can also have mass customization, but again, we have work to do to make that a reality. So you can see some examples, faster setup times, faster time to market, better business responsiveness, ability to test market ideas, much more scalable. You can actually have situations where you have demand happen, have payment happen, and then have production and fulfillment. And so the risk profile of business changes dramatically as well.
One book, or we can print 10,000 books. It makes no difference. And after those 10,000 books, if the next job has 2 books on it, they just come flying right out after it. 1, 10,000, 5, 10, 20, it doesn't matter. They just come out, one after another. Not one wasted sheet in between.
So what you see there is true mass customization. So that is a $5 million production line for manufacturing books on the fly such that every book can be completely unique and different, driven by data. And that's a very powerful mechanism, and it's something that's been realized already. In this case, this guy is the greatest salesman in the world for us. He just does such a great job of articulating the power. You can have high volume production of the same thing over and over and over, and we have great closed loop quality controls to ensure that quality is maintained throughout. But we also have the data processing capability such that every single pixel on every one of those pages can be varied and can be driven at the very last second by data feeding into these machines. And as you think about now moving into the 3-dimensional world, the amount of data, data intensiveness will be incredible. We have fiber optic trunks that run into the machines that you saw there for mass customization. So as much as we need to think about the 3D printing technology, we also need to think about the data processing and challenges there, and make sure that as an industry, we're moving all of the solutions forward, not just one element. So given that I talked about Amazon as an example, I want to talk about the book market because it gives us a retrospective example that we can look at, and we can see factually what happened over time as a digital production technology was deployed to serve that market. So I'll start with this. It's a great quote from Warren Buffett that says that it's only when the tide goes out that we find out who's swimming naked. And in 2008, during the Great Recession, there were a lot of companies that were shown to be pretty naked. And one of the areas this was really clear was in the publishing supply chain. In the publishing supply chain, it's a consignment-based system, and traditionally the publishers own the content. They also do the production or have the production done, and then own all of that as it goes through the consignment system. It sits at retail. The greatest sin at retail is that somebody wants a book and you don't have it there, so the bias is always to have the production there. And then if it doesn't sell, it comes all the way back through that system and then eventually gets dealt with either through repurposing or just being pulped. And what you find in this system is that the truth of the matter is that 30% probably underrepresents the reality of the situation. The challenge is you're trying to match supply and demand, and the traditional systems of doing that were not all that great. It was not easy to test market. It's not easy to ramp up quickly. The traditional processes are based on a master copy and then making many, many copies of the same thing, and everybody historically has focused on unit cost. That is the metric of success. But when you focus on that as the metric of success, what happens is you forget about all the other stuff, such as the costs of overhead and supply chain and so forth. So we worked with a company in the Boston area, and one of the things that I would emphasize is that we partnered with a company. We brought our thermal inkjet technology to them, and they showed us how it could be deployed to help them with their supply chain. And so we supported a number of these production lines, and in this, we were able to show that in a few years, they were able to take, of that 30 to 40% waste that they have in their system inherently, they were able to take 73% of that out. And the way that they were able to do that is that they were able to match supply and demand much more effectively. And it was a very interesting thing. If you look at the profile of how books are demanded, you typically have a first couple of runs that are very high volume, and then it kind of tails out into the long tail. And what happened was, once the publishers really understood that they could order less more often and automate those processes, it became kind of a virtuous cycle. And so the uptake of this technology really started to take off. And so Courier was able to demonstrate, again, taking waste out of the system, taking overhead out of the system. The other thing is it basically made virtual inventory a reality, and so nothing ever goes out of stock. It just needs to be produced. And so that's a very powerful set of capabilities. And ultimately what you find with digitization is there's two main benefits. It takes waste and inefficiency out of the system, and it opens up the opportunity to make completely new things that were not possible before. Okay, so in the case of Courier, what you have is we can look at this and say this is a fact. This is not something that we propose will happen in the future. So, to take the story a little bit further, the question is, Courier does this, they adopt the technology, and they really master digitized manufacturing. And as they did that, what happened was they were able to integrate into the ERP systems of the publishers, automate all of their transaction processing systems, allowed the publishers to match supply and demand much more succinctly. And as a result of that, they became very disruptive in the industry. And so there were two very, very large print manufacturers in the United States who took note of this and realized that they needed to pay attention. And so one of the biggest is Quad Graphics in Wisconsin, and they decided that Courier had really mastered the digital process of production. They needed to acquire that knowledge and insight. And then the other thing they were going to do is order 20 of these production lines, $5 million production lines, in order to really change the way that they're doing their manufacturing to a digitized process. That, in turn, was so disruptive to the industry, to the other major player, that the other major player in the industry counterbid for the privilege of buying Courier. Now, Courier was a second or third tier player in the industry, but because they really mastered digitized manufacturing, they were able to serve their publisher customers in a superior way, and as a result of that, really changed the market for the book manufacturing space. So all of that is context to say that we have something as a frame of reference to look at that is manufacturing, that is digitized, and we can see what the impacts of that are and how it plays out over time. And what I would tell you is that it seemed to take forever, but the truth of the matter is that this all took place in a period of about 5 years, and significant transformation took hold. If companies are making these kind of, $500 million investments. So the question for us as we look forward with 3D is how fast is that going to happen? And to some degree, it's up to us to help drive it forward and advance it. What I'd like to do is switch gears and focus the conversation on the idea of blended reality for us means being able to move things seamlessly back and forth from digital form to physical form. For us specifically today, we're focused on the 3D printing component, and so here's a little video to give you a feel for that.
HP has been on a mission to disrupt the process of innovation and advance the state of the art of 3D printing. By bringing HP's proven expertise in digitization technology to the design and manufacturing industry within reach of everyone. HP is engaging the most brilliant minds through an open innovation platform, so developers, creators, makers, and designers can all realize their full potential. With our 3D printing technology and your vision, together we can launch the next industrial revolution.
So that gives you just a little bit of an inspirational sense of our ambitions. One of the things that I want to make clear, this is a consumer electronics show. How is HP serving the market? Are we focused on the consumer side? Are we focused only on industrial? Truth of the matter is we're focused on all. And however, having said that, the way we feel the best way to serve that is going to be through service bureaus and enterprises and more of that kind of an application rather than the way HP serves the consumer space for traditional printing. And we will serve maker kind of applications, prosumer applications, enterprise applications, both in terms of the process of engineering, as well as ultimately moving into production itself. And we believe that that is viable in the near term, and I think that's a very important thing to make a clear statement on. And again, we say that because of our experiences that we've had over the last 10 to 15 years. So then the question is, what's the strategy for doing that? And the interesting thing is, when we looked at moving our technology into high volume production for traditional print manufacturing, what we learned is that the reason it hadn't really taken hold historically is because we're just not dealing on the right level of performance, the right cost structures, the right levels of productivity. The term I like to use is we were going to a gunfight with a butter knife. And so what we started to do is looking at our printing technologies and thinking about ways that we can integrate them to better serve a much higher volume kind of application. And in the end, it all came down to speed, quality, cost, and it really wasn't much more complex than that. In the 3D printing space, I think we need to add reliability, predictability in order for this to move meaningfully into production kind of applications. And so this is really consistent with how we've always entered markets in the commercial context. There's a couple of things that are unique here. A is the reliability. Now, from HP's perspective, we put millions of machines out into the market. So one of the things that we're very, very good at is characterizing machines and stabilizing technology before we put it out into the market. And as we thought about this market, we thought, boy, that's a great opportunity for us. So this reliability element here, we're going to really focus on that. So then the question comes, what is our strategy in terms of the materials? And this is where we've taken a bit of a different tack. And I think very aligned with what Jennifer mentioned earlier. This market is going to be about the materials. It's going to be about the uses, the outcomes. And so if that is something that's tightly controlled and limited, it's going to really limit the growth and potential of the market. As we look at this market, we see decades of opportunity, but in order to get there, we really have to take some bold steps to move in that direction. So one of the things that we've decided is that for the materials that we're going to use in these systems, we are going to take an open approach. And in fact, what we want to do is make it a platform. And with that platform, we want to make it really, really easy for third parties, maybe material science companies, maybe it's enterprises that want to have their own materials. We're open in terms of our mindset here, but we want to make it very easy for other people to innovate on our technology platform. That's really the key thing there. There is so much white space in front of us that the challenge is being able to take advantage of it and get to it. We believe that we're going to get a lot farther, a lot faster if we allow others to participate on this platform with us. So I say that in terms of the materials, but we also take the same approach in terms of the workflows, but maybe for a little bit different reason. So one of the things that we announced a while back is that we supported and participated in the development of the 3MF consortium. And here the idea is that we want to be able to have a file interchange format that is really built for the future of additive manufacturing. And in order to do that, there's some advancements that are needed. And the amount of sort of quick alignment in the industry shows us that there was maybe some latent demand to really get onto a new platform in terms of these file workflows. The other thing that we did is we announced a partnership with Autodesk on their Spark platform, which again is intended to make it really easy to get from file to print. And that all goes back to taking the friction out between design intent and what's materialized out of these systems. So that's the strategy of the business. Now what I'd like to do is share with you a little bit about the technology. And to understand our technology, you really have to understand something that we've been working on for a really long time. And if my discussion of this is successful, you will have a new appreciation for printing technologies by the end of this. So we use a technology in a lot of our businesses, which is thermal inkjet technology. And the idea is that it is a thermal mechanism that ejects drops in very high resolution. I like the fact that Jennifer used the term nozzles a lot, because when we talk about our thermal inkjet technology, one of the things that we emphasize is the density of nozzles that we can have in a given area of space. Because it is a thermal process that forms, that basically superheats the ink and creates a vapor bubble, that is the mechanism of drop ejection with our thermal inkjet technology. By virtue of that, there's no moving parts on the print heads that we have. And so I'm going to show you the power of that, but one of the things that you get as a result of it being a thermal process is the ability, because it's not mechanical, to have an extremely high amount of nozzles in a small amount of space. I'll show you what those numbers look like. So first and foremost, this is a technology that we've been developing on for decades. And so you can imagine that there's billions of dollars of investment that we now get to leverage. And it's great to build a new business. And make no mistake, we are a startup. You hear the name HP and you may think of a big company, but we are a startup within that large company, held to all the same kind of accountabilities that startups are. With this technology, we have over 4,500 patents just since 2004, to give you a sense that this is a fresh technology that we're continuously evolving. We've completely vertically integrated all the way up to a silicon wafer fab, which is one of the elements, the MEMS technology, that we use to get the very high levels of resolution. And that allows us to have everything under one roof, and by virtue of that, we can really have accelerated innovation, have lots of different instantiations of that technology in a short period of time, and fundamentally it gives us superior cost structures. So as I mentioned, 30 years of innovation on this technology, and one of the things that may not be intuitive, but I'm really captivated by the idea of doubling. There's a book out now called The Second Machine Age that I've been reading, and this idea that things kind of have this Moore's law kind of dynamic where performance doubles, and it seems to kind of go at a certain pace and then really take off. We have maintained for the life of our development in thermal inkjet technology that same kind of Moore's law performance dynamic, and we don't see that ending. And we continue to invest in this technology, and I'll show you some examples. So I want to be clear, we're not going to start with machines that are massive manufacturing machines, but I wanted to give you a feel for things that we've already done with this technology to give you a sense of its scalability. Fundamentally, the elements are common, whether it's all the way down to consumer applications, all the way up to very high volume uses. And in the case here, what you see is arrays of print heads. The elements that you see there arrayed across are print heads. Each of those print heads has 10,560 nozzles in it, and each of those nozzles has the potentiality to fire 48,000 times a second. On that particular machine, which was on the book manufacturing system that I showed you earlier, there's 200 of these print heads. So 200 times 10,560 times 48,000 times a second as a potentiality means there's a whole lot of ones and zeros. And so again, the data intensiveness is very, very important to have your arms around, and this is something that we've been working on for a long time. And so here you can see that it's also a very scalable technology. So the approach that we've taken at the silicon elements that are on the print heads to the ability to stitch the print heads across wide arrays. We have a machine today that is 2.8 meters wide. So that is 110 inches across, which we are imaging at about 600 feet a minute. We have other systems that go up to 800 and 1,000 feet a minute. So that is a lot of imaging power that we can now take and apply to 3D printing. Now, what I want to do is change the way you think about thermal inkjet technology. It's not, well, it is what has been in your home and office and graphic arts applications kind of uses, but this is really a precision delivery mechanism. And so this is a product that we use in pharma and life sciences space for very precision drug delivery, for accelerated drug testing. This is just a number of a wide range of applications that we can use for our thermal inkjet technology. So now let's start thinking about how are we going to apply that to multijet fusion. In the simplest sense, this is the basic framework for our first implementation of multijet fusion. And so what I want to first go through is very high level, very fast, the basic idea. And then I'm going to step back and ask you to take a bigger look. So take, for example, a material. Let's say in this case that it's a nylon powder. We have a powder bed approach, and into that we image with our thermal inkjet technology areas, and we apply agents applied by the printheads. Now, when people hear printhead, printing, or inkjet, what they immediately think of is binder jetting or things like that. In this case, what we actually do is we use a chemistry to differentially absorb energy, and by virtue of that, define the area where melting should happen. At the same time, one of the other chemistries that we spray down is something that inhibits melting. And so we can have very clearly defined boundaries where we have fusing happen versus where it stops. We apply energy, and then we repeat the process over and over. So, again, it's important in this case to internalize that it's a thermomechanical process that results in superior melting between layers. And part of that comes because we're able to have very clear definition on where we want the fusing to happen. We're also able to dwell the energy over the material bed for a long enough period of time that the interlayer bonding is much stronger. And then we use an agent, which is represented by the blue dots there, to define the boundary and where we want the fusing to stop. So the thing that's unique about HP is that we have multiple agents of chemistry that we are spraying into the bed. That's the thing to really focus on. So if you think about it, with the materials process, what we've said is that we're open in terms of approach there. In this case, what you see is a powder bed, but it could be powder, it could be a paste, it could be a slurry. There's a variety of different approaches that we could take there. In terms of the agents, in this case, what you see is a thermomechanical process for fusing, but it could also be that we have reactive outcomes as well. And then in terms of applying energy, we use light as a means of radiating energy into the bed, but it could be that we use a wide variety of other sources for energy as well. That is really the framework of multijet fusion technology. So that's a lot to take in. What I'll do now is show a little animation that'll explain it in a little more detail.
HP's Multijet fusion technology produces high-quality, functional parts at a production speed which is 10 times faster than today's competing products. Unlike the slow point processes of some current technologies, HP's Multijet fusion technology processes parts in 2 fast area-wide passes to achieve top-speed part production. The process begins by applying a layer of material in a work area. Then, in one continuous pass, we print liquid agents across the full working area using HP thermal inkjet arrays. In the opposite direction, we combine the layering and energy fusing into one continuous pass. This HP proprietary architecture, using HP's thermal inkjet arrays, is capable of printing 30 million drops per second along every single inch of bed width. To achieve part quality at speed, HP invented a multi-agent printing process. In this process, a fusing agent is applied on a material layer where the particles are meant to fuse together. A detailing agent is applied to modify fusing and create fine detail and smooth surfaces. The area is exposed to energy, and reactions between the agents and the material cause the material to selectively fuse together to form the part. The process is then repeated until a complete, high-quality, highly functional part has been formed. This is how HP's proprietary area-wide processing compares with today's popular point processing technologies for building functional parts. In the time it takes these slower point processes to build 1,000 parts, HP's Multijet fusion technology would have created several thousands of parts. Using HP's proprietary multi-agent printing, the HP Multijet fusion technology achieves new levels of part quality at these breakthrough speeds. Taking advantage of HP's in-depth knowledge of color science, HP's 3D printers could selectively print a different color at each volumetric pixel. A single 3D printed part could have literally millions of colors. But more than just color printing of functional parts, the future of HP's multi-agent innovations could enable realizing the full potential of 3D printing. At each volumetric pixel, or voxel, HP's transforming agents could control surface texture, wear, and friction. HP transforming agents could control the translucency of each voxel. HP transforming agents could allow one to optimize the strength and stiffness in portions of a part and to print elastic voxels in other portions of the part. HP transforming agents could be used to change the conductivity of certain voxels. HP transforming agents could also be used to enable the printing of new advanced materials or enable emulating different materials at each voxel. HP's Multijet fusion technology could enable design and manufacturing possibilities that surpass the limits of our imagination.
So that's the really big idea, is that the approach that we want to take is to be able to manipulate the properties of parts at the voxel level. But in order to do that, there's a lot of work that needs to be done between here and there. To give you a sense of it, you probably can't see it all that well from here, but this is a part that is a multicolored part, and in and of itself is probably not that compelling. But if you looked at this and looked at the color as an analogy, what you have here is a gradient that is being manipulated through the volume of the part. And that's being digitally defined all the way through. There's no software workflow tool for doing this today. And part of why we had to announce early that our product was coming to the market was so that there would be the ability to take advantage from a design perspective of these kind of capabilities. So I'm just going to take a minute and quickly show you some examples of parts and wrap things up. The thing to really understand about our approach to 3D printing is that the functionality is really the thing that we've put our greatest focus on. And so what you actually see here are parts from our 3D printing system that were produced with our technology. They are very much engineering thermoplastic, production quality materials. Very high resolution and very high accuracy. In this case, this assembly could have been done all in one piece, but we actually printed all the elements in different places around the bed to see if we could assemble it and have accuracy be good enough that it would be functional, and it is. I'm going to quickly scan through. Here you see accuracy good enough that traditionally molded parts could be applied to it. In this case, this is a light fixture where there's actually no wires. We were able to sort of 3D wire the system. And we made a pair of scissors, and I want to show you that even with thermoplastics, the accuracy was high enough that we're able to cut with those. You can see with color, we can be in very high degree of detail and accuracy. But probably most important is this one, because it just gives you a sense of, these are real non-frail thermoplastic kind of uses and applications. In this case, you see an example of parts using the same material that create very different outcomes just by the design itself. And so here you see this is a pair of scissors that is printed just with, this is nylon in this case, completely functional. So you get the idea. So this I like to share because it's kind of representative of where we need to go. This is a gradient of color, but it's a gradient through the volume of a part. And we really need to work to advance the state of the art in the industry, working collaboratively together so that customers can take advantage of these kind of capabilities. So from our perspective, HP is bringing a breakthrough platform, but we really view that digitization is the megatrend that we are all riding on. We need a breakthrough solution to really advance to the next level in terms of price performance, speed, quality, and cost. And for us, thermal inkjet is really the heavy, broad shoulders that we stand on in order to advance this technology. And our strategy is that of a platform. Finally, I want to emphasize a few key things. HP historically is a quite big company, but we really have the heart of a startup. And we mean that both in terms of how we engage customers. We're very humble in terms of how we engage, but the other thing is that we're taking a very open approach for growing this business. We want to have business models that are designed to help new markets grow, and probably most important of all is necessary and very, very important to partner to bring the end-to-end solution together to fully realize the benefits of additive manufacturing. And with that, we'll stop with the idea of keep reinventing.